Hi, Bron. Let's take a look at what you did on the homework set for Chapter 8 and Chapter 9, okay? Okay, first problem. Let's see. Doing a confidence interval here. There's your x bar, your sigma. That looks good. And your confidence and your alpha, that's good. Critical value looks good. Okay. So my margin of error is going to be the critical value times this. Of course, that's just 1. And your upper and lower, you're just going to add and subtract from that. That looks good. Okay, excellent. Let's see, for number 2. This is number 2, okay? Same sort of deal, right? That looks good. Looks good. All right. So, so I believe this is number 15. It's labeled 3, but I think this is 8.15. And what we're asking here is we're asking, what does the confidence interval mean? Okay. So, you know, we have this intuitive sense that the confidence interval contains the population mean. So that part's pretty obvious. But there's this question of what does confidence mean? So I'd like you to go back, go through the book, and try to figure out what that 95% confidence means. I'll give you a hint. It's a statement about the method. It's not the probability that the population mean is in the interval. Okay? Once you construct a confidence interval, the population mean is either in there or it's not. There's no more probability. So it's not a statement about how likely the mean is to be in there. It's a statement about the method. And we did talk about this in class. So go back, look at your notes, and look at the book in that section. Okay, so now we're looking at section 8.2. All right. So let's see. Problem 11, we're computing another confidence interval. Of course, the difference here now is that we're using the t-distribution, right? And we have n minus 1 degrees of freedom. That looks good. The margin of error is the critical value times standard deviation of x bar, which is exactly that. And then we just add and subtract that. Very good. Okay. So for 12b, we're just finding the critical value. So actually, that part's really easy. So for 12b, you just want to find the critical value, and you've been doing that. Okay. So that shouldn't be hard for you. That should be pretty straightforward. Okay. Let's see. 8.16. Again, we're finding a confidence interval, and really, it's exactly the same sort of thing that you did in problem 11. So basically, if you just redo what you did in 11 and 16, you'll be fine. Okay, let's see, 9.1. So 9.1 has a couple of interesting problems. So in problem 1, we're just asking whether or not we would reject the null hypothesis, okay? Here, the p-value is what we need. Let's see. So here's a problem. We need, okay, in problem 1, we need to be able to explain why we would reject it or not reject it. Okay? So one way is to compute the p-value. All right? If you compute the p-value of this, it'll tell you whether or not you should reject it. In 4, basically they just want the decision rule. Okay, so in 4, you're just going to say, if I know alpha is equal to 0.01, how am I going to decide whether or not to reject the null hypothesis? What rule am I going to use? So that's step 4. We call that the decision rule. So this is a very simple one, a very short one. Let's see. For 9, I'm not sure what's A, B, and C. Right, so the null hypothesis is not guilty. The alternative is guilty. I don't see any more work, though. So, but basically, you're on the right track. This is how we start off thinking about it. And then if you look in the book, it talks about type 1 and type 2 errors. And this is extra credit. You're not required to do this, okay? It's just if you want to. And 11, if you want to do that, you can do that. Let's see, 14. Okay, so this was just, this was both a hypothesis test and a confidence interval. There's lots of points there. And there's also 16 too, so we need to do 16. Okay, so 16 also has to be done. There we go. Okay, finally 9.2, let's see. So we're going to start off with problem 18. Okay. And basically we're just computing the value of the test statistic. So given this hypothesis test and this information, what is a test statistic? So we need to compute that. Degrees of freedom is good. Okay. 22 is actually in the book. 22 and 23 are in the book. So I'd urge you to go back and look and see when you can use the actual t-test. We didn't go into that a lot, but that's important, and that is in the book. Let's see. So here we're doing a hypothesis test. This is our mu naught. Okay. That's our x bar. So we need to state what the alternative is. We have to be careful. This is not, there's going to be a problem, I think. Oh, no, it's okay. Never mind. Yeah, that's all right. Okay. Let me see real quickly. There's actually a problem here, so you need to be careful. There's a computational error here. Okay. Think about what the sign of the test statistic should be. You're trying to prove that it's less than. So this test statistic should have a negative sign, okay? So you have to be careful how you compute that. The p-value is off. And you have to be careful because when it's positive, you have to compute the upper percentile, but it's not positive, okay? So once you correct this, that should also be corrected too. And it's good, you didn't multiply this by 2. So, okay, last one. Okay, so we wanted to check and see if this was going to have a normal distribution or somewhat symmetric. It's clearly not. And we still want to do the hypothesis test though. So we still need to do the hypothesis test here. Okay. So that part's missing, I believe. Okay, so those are pretty much the redos. Definitely some blanks we want to fill in, you know. And if you have any questions, feel free to ask.